Hi friends, let us continue our discussion. Before going to the next point, that is Newton's second law. One point I skipped from previous one, that from Newton's first law, that I will discuss first. So this is the point related to Newton's first law. That is, one car moving is due to external forces. A car moving is due to external forces. There is no internal force which causes acceleration to the car. Here consider initially car at rest. It is at rest. F is equal to 0. Now the car is accelerated by some external force and thereby it is picking up speed. So its velocity is increasing. Velocity increase. Acceleration is not equal to 0. F is also not equal to 0. Second case. It is accelerated or by external force and therefore it's a picking up velocity. After some time, car starts moving with uniform velocity along a smooth road. That is uniform velocity. Speed is constant. So it is constant speed. It's a uniform velocity. Car is moving. Now see, in this situation, what is actually making car accelerate? It is not the internal forces, but these are the external forces. The car is accelerated because of external force. No internal force caused any acceleration to the car. And only conceivable external force is force of friction. Therefore, the force of friction is causing car to accelerate and there is no internal force in picture. This is a very important thing. Therefore, whenever we talk about acceleration, we consider external forces. We do not consider any internal forces. This was the topic, or this was the point from previous one, that is the Newton's laws of motion. Now we move to the next point, that is Newton's second law. It is very important and basic law of nature. It's a 5.5 Newton's second law. Newton's first law gives an idea of simple case where the force is 0 and therefore acceleration is also 0. Either it is a rest position or uniform motion in a straight line. So here the force was considered to be 0. But Newton's second law, if force is not 0, if there is a certain non-zero external force is acting on the body, then what happens? And here, when external force is acting on the body is accelerated. The velocity of the body increases. And then, this is the basic discussion in Newton's second law. The statement of Newton's second law is that the rate of change of momentum is directly proportional to the force acting on the body and it is in the direction of force. Now here we are taking it momentum. Why do we need to consider momentum? In this Newton's second law, why do we consider momentum and what is a momentum? This thing first we will discuss with some examples. Let us talk about momentum. What is momentum? Momentum is product of mass and velocity. Once again I say momentum is product of mass and velocity. Momentum is denoted by V, it's m into V. Mass is a scalar quantity and velocity is a vector, therefore momentum is a vector quantity. Momentum is a vector quantity. Unit of this momentum is SI unit becomes kg, meter per second. CGS unit becomes gram, centimeter per second, and dimensions are, dimension becomes m1, l1, t minus 2. It's a combination of two, mass and velocity. And what was the need of this physical quantity momentum? Let us discuss few examples. First example, one is a heavy truck and one is a light car. Both are at rest, and suppose we want to set them in motion. Now, car and truck, we want to set them in motion with the same speed. We want to make them move with the same speed. Velocity of truck and velocity of car must be same. We want to push them. Then this speed again they must acquire in same time. After pushing, suppose that the time taken for truck to achieve the speed must be equal to time taken by car to attain that speed. These two conditions are, in which case greater force is required. And simple answer is, in case of truck, more force is required as compared to car. It indicates that if mass of the object is more, the more force is required to attain same velocity in same time. So the mass is one factor which impacts acceleration, or which is mass is a factor on which the effect of force depends. One more example in this case, lighter stone and heavier stone is released from some height. Then which stone you will find to catch easier? Obvious question is lighter stone. As compared to heavier, we need less force to catch lighter object. Again, we can see that impact of force depends upon mass. Second example, the bullet fired by gun easily pierces in the body and causes fatal accident. But same bullet, suppose we throw with the hand, it will just brush the body. So what is the difference in the bullet fired from the gun and the bullet thrown by us? The simple difference in this one is that the bullet fired from the gun is traveling with the greater speed or more velocity as compared to the bullet thrown by us. Therefore, if the speed is more, if the velocity is more, then the impact of force is more, or impact of force depends upon velocity of the object. So this is second parameter. By using this one, we can correlate. There are two things. One, already we have seen mass. Second case, we have seen velocity. Fourth example, I am discussing it here. Seasoned cricketer find it easier to catch the ball as compared to the new one. What is the reason? Seasoned cricketer learn how to catch the ball, and whenever seasoned cricketer is catching the ball, he pulls his hands in backward direction, in back direction along with the ball. It means that the time of contact of ball and hands he increases, but novice, new one, is just suddenly stopping the ball and thereby getting hurt because of the speedy ball. The reason is there, the time of impact, time taken to catch the ball by seasoned cricketer, by experienced cricketer is more as compared to the less experienced one, and due to this one, impact on novice is greater. He is getting hurt. So this is third factor, that is the time of impact is also important, and therefore this Newton's law was summarized by considering these three factors. So far we have only discussed the change in velocity along straight line, but we can even discuss the change in velocity when the direction is constantly moving. Consider circular motion. In this one, the velocity direction is continuously changing. There is one stone which is revolved in a circular motion, which is tied to the string. One end of the string is held in hand by the person, and other end where the stone is tied, it revolves in a circular orbit. If the speed is increased, then the person who is providing force to rotate this stone has to provide greater speed. If the velocity you increase, more force is required. At the same time, if the radius is decreased, if the radius of this one is decreased, in such case also the person who is providing force by revolving stone has to provide more force. In both the cases, when the speed will increase or radius will decrease, we are increasing acceleration. Therefore, when more acceleration or when more momentum change is required, more force is needed. So in all together, we can summarize this one, and this is given by Newton, and the statement comes here like this. The rate of, this is the Newton's second law. The rate of change of momentum. Is the rate of change of momentum is directly proportional. Directly proportional to the external force acting on the body, and this change is in the direction of force. Direction of force. This change is in the direction of force. This is the statement. The rate of change of momentum is directly proportional to the external force acting on the body, and this changes in the direction of the force. This is the basic law of nature. This is the most important law Newton has given. It is applicable to all bodies of this universe, from electron to any planet, electron to all Milky Ways. Now this comes the definition of this one. Let us consider the relation between, there is a relation which we call it as F is equal to ma. We will derive this relation. Let us consider P. Initially P is m into v at time t1. Momentum is p1, m1 v1 at time t1. P2 is a momentum m2 v2 after time t2. Now this momentum, there is a change in momentum. Change in momentum, if the mass of the body remains same, m1 is equal to m2, delta p is equal to m delta v, that happens within time delta. Mass remains same. Now force we saw by this one, there is a directly proportional dp by dt, which gives us k d by dt mv, which gives us km dv by dt. dv by dt is nothing but acceleration, therefore f is equal to km into a. Proportionality constant a is equal to 1. F is equal to m into a. This is the famous relation, force is equal to mass into acceleration. From this one, this we have gone through this by calculus method. By simple algebraic method also, F is equal to delta P by delta T we can indicate. That is P2 minus P1 divided by T2 minus T1. mv2 minus mv1 divided by T2 minus T1, which is equal to m v2 minus v1 T2 minus T1, which is nothing but m into a. This is Newton's second law. That is, this is by using simple algebraic method or average velocity. Now, once again I repeat from this one. What is the Newton's second law? The rate of change of momentum is directly proportional to the external force acting on the body, and this change is in the direction of force. We got relation F is equal to ma, F is equal to ma also. From this law, we define SI unit of force. What is the SI unit of force? From this one, we are defining SI unit of force. SI unit of force is Newton. We write it like this or we write it like this. When you are using name of the scientist to write the unit, this letter should be small. SI. In SI, unit of force is that force which accelerates body by 1 meter per second, 1 kg body by 1 meter per second. So we can take this one, basis of F is equal to ma. This is 1 Newton, which is 1 kg into 1 meter per second square. So 1 Newton is that force which required to accelerate 1 kg mass by 1 meter per second acceleration. Once again I say 1 Newton is that force which accelerates 1 kg body by 1 meter per second square. This becomes SI unit of force. There is a smaller unit which is known as dyne, that is 1 gram into 1 centimeter second square. So 1 dyne is that force which accelerates 1 gram of body by 1 centimeter per second square. Here now, these are the two things. Let us find out relation between them. 1 Newton we say it is 1 kg, 1 meter per second square. This is 10 raised to power 3 gram. This is 10 raised to power. So if I take it, it becomes 10 raised to power gram centimeter second square. 1 Newton is equal to 10 raised to power dyne. This becomes the relation here. Some important point about this Newton's second law. First one, that is, it is inconsistent with Newton's first law. See that F is equal to m into a. If it is equal to 0, force is equal to 0, acceleration is equal to 0. It means either it is at rest or uniform speed or velocity, uniform velocity. So this is also explaining first law. Newton's second law is also explaining first law. Second point about that, this was the first law. Newton's second law is in vector form. That is, F is equal to dp by dt. Now, F we know, F is equal to fx I plus fyj plus fzk. Ijk unit vector along xyz. Now this dp by dt, we can write it as dp by dt, dp x by dt I plus dp y by dt j plus dp z by dt k. Comparing this, fx is equal to dp x by dt, which is equal to m, that is dv x by dt, which is equal to max. One equation. Similar manner, fy is equal to dpy by dt, which is equal to m dvy, velocity y direction component, which is equal to may. It is y acceleration component. Third one, it is fz is equal to dp z by dt, which is equal to m dvz by dt, which is equal to. So for example, if the force is along x direction, then force is along x direction, then only Vx will increase. This will change. There is a change in Vx, or Ax will be, acceleration will be along x direction. Similar manner, force is along in opposite direction, that is minus x. Delta x will be negative, that is minus acceleration. So along parallel and anti-parallel direction of the force, acceleration will change. Same thing happens along y and z also. If the force is along positive z, velocity will increase along positive z and there will be acceleration. But then if it is inclined, in case of projectile, velocity is here. See that, in case of projectile, velocity was here. Now it is a Vx is equal to V0 cos theta. It is Vy V0 sin theta. Now acceleration is minus g. Acceleration is anti-parallel to this one. Therefore, only this will change. This force, gravitational force, will not have any impact on the velocity component, which is along x direction. So the force does not change the component of velocity which is perpendicular to the direction of force. It only changes that component of velocity which is either parallel to the force or anti-parallel to the force. Next point, that one is, that is, whenever we are talking about this force, we apply it to the body. But object, any body is a combination of many small minute particles. Now at which point we apply this force, and here the external force is always applied to the center of mass. We consider that the center of mass is the point where the force is applied. We do not consider other particles. In this one, only external force is considered there. No internal forces are considered. This was the third point. Fourth point is that this F is equal to ma is a local relation. It is valid. It is true for that time and that instant. Acceleration here and now is produced by force here and now. There is no previous history considered when we are taking acceleration into account. These are the all points related to Newton's second law. One problem is there, solved problem from book. We will discuss that problem too. Let us see the problem. What is? I read the problem. 5.2. A bullet of mass 0.04 kg moving with a speed of 90 meter per second enters a heavy wooden block and is stopped after distance 60 centimeter. What is the average resistive force exerted by the block on the bullet? It's a bullet is hitting. See that. First, there is a block. In this one, given things we can check it. It's a 5.2, problem number 5.2. This is the bullet. This is the block. Mass of bullet is 0.04 kg and then velocity of that bullet is given as it is 90 meter per second square. 90 meter per second square. And it is, distance is 60 centimeter. This hit and this distance, it is traveling 60 centimeter. A force is asked. To get a force, we must know acceleration. Now S, let us see. S is equal to ut plus half at square 180, or we can use it v square is equal to u square plus 2as. This is more convenient. Final velocity here it becomes 0. Initial velocity is 90 square. 2a into 60 centimeter, we can take it as minus 2. So minus 2a into 60, 10 raised to power minus 2, 90 into 90. Therefore, minus a is equal to 90 into 90 divided by 2 into 60, 10 raised to power 2. Getting cancelled. If you check it, this one is 2, this one will be 3, 27 by 4. It is meter per second square. Acceleration minus a is. So a is equal to minus 2700 by 4. 3, 27. 2 are there, one more will come. This is meter per second square. It is, when calculated, it became minus 6750. We can take it, that is minus 6. 4 are there, 3, 7, 5, 0. This became acceleration, it's a retardation. Force is equal to m into a. Force is 4 into 0.04 27004, it is 0.01. 2 will go, it is 270. Force will be equal to 270 minus 270 Newton. It's a stopping force, therefore negative. That's all for Newton's second law. Thank you.